All right. So remember, we said each of these separately equal to 0. So tan squared x minus 3 equals 0, and sine x minus 1 equals 0. So we add 3 to both sides, and then I take the square root. So it's plus or minus the square root of 3. If it's plus or minus, you need whatever angle that is in all four quadrants. Okay? If it's plus or minus, you need whatever angle that is in all four quadrants. So root 3 for tangent is what angle? 60. So x equals 60, but you have to also have 60 degrees in quadrant 2, 3, and 4. So that would be 120, 240, and 300. Okay? And then over here, we have sine x equals 1, so x would equal 90. Okay? All right, so let's take a look at number 5. Number 5 is just like the warm-up. Okay? Number 2, so we want to look and see what these have in common, right? So this has tan x, this has tan x, so I can pull that out. So I have tangent x, root 2 cosine x minus 1. Okay? Once I'm here, I just set both parts equal to 0. So tangent x equals 0, and root 2 cosine x minus 1 equals 0. But root 2 applies to the tangent and the cosine, so as long as I keep it on one of them, it's fine. Okay, so tangent x equals 0 at 0 and 180. Okay? Here you add 1, divide by root 2, so you get cosine x equals 1 over root 2. Again, that's not something I'm used to seeing, but you know you should be starting to realize if you rationalize this, you get root 2 over 2. So when does cosine equal root 2 over 2? 45 degrees, and where else is it going to be positive? Think of all students take calculus. It's cosine, so cosine's positive here. So that's 45, so 315. So your answer's 0, 180, 45, and 315. Okay? Number 6. Okay, so we want to isolate sine squared, so I'm going to divide by 2. So you get sine squared x equals 1/2. What would I do next? Square root. So you get sine x equals the square root of 1 over 2 plus or minus. Anytime you take a square root, it's plus or minus. Right, so this is going to end up being root 2 over 2 because this can simplify to plus or minus root 1 over root 2, which is plus or minus 1 over root 2, which we just said if we rationalize is root 2 over 2. So x is going to be 45, but again, it's plus or minus. So you need it in all four quadrants. So it would be 45, 135, 225, and 315. To get the other angles, you're just looking at the, so this has to be a 45-degree reference angle. So this is 180. So you could just do 180 minus 45, right? To get this one, 45 degrees, you just do 180 plus 45. I also need 45 degrees here, so you would just do 360 minus 45. 10. So this is one we see that we don't have the same trig function, and we have a square. When you have cosine squared, we know we can change that to sine squared, right? So that would be my first move. 3 sine t equals 2, 1 minus cosine squared t. Distribute, so 3 sine t equals 2 minus 2 cosine squared t. Yeah, 1 minus sine. Thank you. 1 minus sine squared t, sine squared t. Right, so then we would want to add 2 sine squared t and subtract 2. So you'd get 2 sine squared t plus 3 sine t minus 2 equals 0. Right, change it to x's or t's, whatever you want. 2x squared plus 3x minus 2 equals 0. So from here we would want to do the ACB method. So you get 2 times negative 2 is negative 4. Add up to 3, so we want two values that multiply to negative 4 and add up to 3. And those would be what? 4 and negative 1. So 2x squared plus 4x minus x minus 2. Do the boats, factor by grouping. So I can take out a 2x, take out a negative 1. So you get 2x minus 1, x plus 2 equals 0. And then remember, we have to remember to substitute sine back in, okay? So we substitute sine back in. So 2 sine x minus 1, sine x plus 2. So I set now both of these separately equal to 0. So 2 sine x minus 1 equals 0, and sine x plus 2 equals 0. So I add 1, divide by 2. Sine x equals 1/2. Where does that occur? 30 degrees. And where else is sine positive? Where else is sine positive? Right, 150. This is 30 degrees, so you just do 180 minus 30, 150. Let's look at this. You get sine x equals negative 2. Think of the graph of sine x. What is its minimum value? Does anyone remember? Negative 1. So is sine x ever going to equal negative 2? No, so that's just no answer there, so you just get 30 and 150. So today's lesson is proving trig identities. So we've done simplifying, we've done solving, now we're doing proving, okay? The process is the same, it's just that now we have a different goal in mind, okay? So you're going to be given something like this, all right? Cosecant x minus sine x equals cosine x cotangent x. If we're proving trig functions, what do you think I need to do? No, I just need to prove that they're true. That's it. So it's basically like you're given your answer. You just have to find a way to get there. Yeah, it's a proof. You're proving. Okay? So typically what you want to do is try and pick the more complex side and work with that one. Okay? Because it's easier to go from complex to simple than simple to complex with these types of problems. So this one, it's kind of hard to differentiate, but I think we should pick this one. Okay? So what do you see that we could do with this problem? Change it to sine and cosine. Very good. So cosecant becomes what? So 1 over sine x minus sine x. What would this be over? Okay, and we want it to equal this. I'm just going to put equal. We know we have our end in mind. Okay, think about this to use our end in mind. What did I tell you we should do whenever we have a subtraction or an addition? What do we want to get? Yeah, good, India. Get a common denominator. So what do I need to multiply this by to get a common denominator? Sine x over sine x. Very good. Excellent. So what I'm going to end up getting is 1 over sine x minus sine x times sine x is sine squared x over sine x. And again, I'm going to here. Some of you guys might already be able to see what's happening. Okay. Now I have the same denominator, so I can put it over 1. So 1 minus sine squared x over sine x equals this. So now I need to somehow get a cosine and a cotangent. What does 1 minus sine squared equal? Excellent. Cosine squared. Does anyone see a way now I can get from cosine squared x over sine x to, this should not be 0, I'm sorry. This should be cotangent x, cosine x. Or the other way around. Backwards? I mean, it doesn't matter. Cosine, cotangent. Doesn't matter. Good. So that would just be cosine x over sine x. Any ideas now? Cosine over sine is cotangent. So that would be now cosine x times cotangent x. And we've done it. This is probably one of my favorite things in this class. The proving. Because don't you just feel so much like accomplishment right now? I do. All right, take a look at this one. Very similar setup, right? What do you think the first step should be? Do the left side, and what should my first step be? Sine and cosine, right? So once you're here, what do you think you would do? So, like I said, the first step is to get a common denominator. So I multiply by cosine over cosine, multiply by sine over sine. So you get cosine squared x over cosine x sine x plus sine squared x over cosine x sine x. I have it over the same denominator now, so I can make it one fraction. What does cosine squared plus sine squared equal? Everyone should know at this point that equals 1. What is 1 over cosine x? Secant. What is 1 over sine x? Right, so you get secant cosecant x, which equals secant cosecant x. All right, so these both look pretty similar, yeah? So, well, hold on. Let me give you a hint. What did I say yesterday to do whenever you have like 1 plus cosine x here? What can we do? What can we multiply by? No. Not by itself, but by you're changing. Not the reciprocal. Right. 1 minus cosine x. That's called the conjugate. So you multiply by 1 minus cosine x, 1 minus cosine x. This one's going to work out really nice. Okay? So look, the denominator here, that's a difference of squares. So you have 1 minus cosine x times sine x over 1 minus cosine squared x. 1 minus cosine squared x is what? Sine squared x. So you get 1 minus cosine x, sine x, over sine squared x. Now what can I do? What if I have sine x over sine squared? What can I do with those? Cancel this out. This square goes away, so you're left with 1 minus cosine x over sine x. And look, it's the same.